That Crash Course Instrumentation, Episode 7, When Circuits Go Wrong, Opens, Shorts, and Faults. Welcome back to Crash Course Instrumentation. In this episode, we're shifting gears to talk about what happens when things don't work as planned. We're diving into why circuit faults, specifically open circuits, short circuits, and unexpected failures that can throw off measurements, damage components, or shut down entire systems. Let's start with an open circuit. An open is exactly what it sounds like, an interruption in the path where current is supposed to flow. Maybe it's a broken wire, a blown fuse, a loose terminal, or even a bad solder joint. In an open circuit, current drops to zero. Voltage may still be present, but it won't cause any flow. The load receives no power. It's like a water pipe with a valve fully closed. Pressure might exist on one side, but nothing's flowing. In real systems, opens can cause sensors to stop reporting, motors to stall, or control loops to freeze. Next up is the short circuit. This happens when a very low resistance path forms between 2 points, often where it's not supposed to. It could be a frayed wire touching ground, moisture bridging terminals, or a failed component that now passes too much current. In a short, current can spike dangerously high. Voltage drops across the short. Components can overheat or fail instantly. Imagine connecting a battery's positive terminal directly to its negative terminal with a thick wire. There's almost no resistance, so the current shoots up, and unless there's a fuse or protection circuit, something's going to burn. Shorts are serious business. They can take out sensors, destroy power supplies, and sometimes even damage people. That's why every good system includes fuses, breakers, or current limiters. Now let's talk about less obvious faults. The ones that creep in slowly or only show up under certain conditions. Intermittent connections that cut out when a machine vibrates. Corroded terminals that increase resistance over time. Water intrusion that creates leakage paths across connectors. These can be tricky because the system might work fine one day, then glitch the next. You might see fluctuating current readings, voltage that looks normal until a load is applied, sensors that drift or drop offline under load. This is where your skills as a tech really shine. Using a wide multimeter, loop calibrator, or even an oscilloscope, you can catch these faults by watching for unexpected voltage drops across what should be a solid connection, current that doesn't match expected values for a given load, power supply voltages that sag under demand. Graphing also helps here. A time plot that shows sudden drops in voltage or spikes in current can reveal when and how a fault occurs, even if it's intermittent. And don't forget the power of visual inspection. Look for signs like burned components, discolored wires, loose terminal screws, water stains or corrosion around junction boxes. Every experienced tech knows that bad connections cause good equipment to behave badly. Let's recap the main fault types. Opens. No current, even with voltage present. Think broken wires, loose terminals, blown fuses. Shorts, massive current, no resistance. Think melted insulation, accidental bridges, water damage. And then intermittent hardest to find. Look for corrosion, vibration, or thermal expansion issues. And remember, always isolate power before probing unknown circuits. Use proper test equipment and PPE. Log your measurements. You'll thank yourself later. Thanks for tuning in to Crash Course Instrumentation. In the next episode, we'll zoom out and look at complete loops, how voltage sources, loads, and signal wiring come together to form functional instrumentation systems. Don't forget to like, subscribe, and drop a comment about the weirdest fault you've ever had to track down. Stay sharp and see you next time.